few days we've been talking about parallel and perpendicular lines from graphs. Okay? So how can we tell if lines are parallel or perpendicular? What do we know about parallel slopes? They're going to be the exact what? The same slope. But perpendicular slopes they're called negative reciprocals. So how do we compare them? I'm going to show you an easy way how you can compare them. So the first thing we're going to do is I'm going to make a little table here. So I'm going to make a little table with these ordered pairs. These will be in blue. If I were doing this problem, I would jot this down. And I'm going to make a table right here in green. -4, and a 6, and a 6, and a -9. Now all I'm looking for is like the gap. What's the change in y over the change in x? So right here, if we looked at this, if I went from -4 to a +4, I would have to add 8 to get there. -4 plus 8 is 4. If I went from a -7 to a +5, wow, I'd have to add 12. So my slope right here with this set of ordered pairs is going to be 8 over 12, which reduces to 2/3. Okay? Now, this is just an easy way to find slope without having to use the slope formula. Obviously, you could use y2 minus y1 over x2 minus x1. So obviously, you could use the slope formula and plug it in and do the exact same thing. This is just a fast way for me to get it without having to do a big formula. Now, if I went from a 6 to a -9, looks like I dropped down 15. So I took 6 minus 15 gets me a -9. If I went from a -4 to a 6, that means I would have to go up 10. So this is going to be, what's my change in y on this one? -15. What's my change in x? +10. And that reduces to -3 over 2. Now, if you look at these, 2/3 is the negative reciprocal of -3 over 2. So this answer is going to be, these points are perpendicular. Now you have technology that you can use to check the slope. So we're going to do it by the graphing calculator. If you ever want to find a slope in the graphing calculator, hit Stat, Edit. I'm going to go ahead and delete these ordered pairs out of here. L1 is your x value, L2 is your y value. So if I went back, I could type in a -7, -4. And I could type in a 5 and a 4. Hit the Stat button, go to the right, go down to number 4. And you guys have practiced this a lot. And what does it calculate? It calculates the slope. What's the only thing you have to do? You have to know how to convert what? 0.666 to a 2/3. If you didn't know that 0.6 repeating is 2/3, then you literally have to type in 0.666 numerous times in your calculator, and then you can change it to a fraction by hitting the math button and pressing enter twice. So that's how you find slope in the graphing calculator. Now the last thing we're going to do is we're going to show you how to find slope in Desmos. So here we go. I'm going to take these ordered pairs, -7, -4, 5, and 4, and I'm going to type them into Desmos. So what you do is you add a table. So I'm going to type in -7, -4, and a 5, and a 4. Now, in order to interpret the slope, you have to remember this. Y1 tilde mx1 plus b. And that interprets the slope. Notice, you can see the slope now. It's at 0.6 repeating. And it plots your ordered pairs right there on the left of the, not the ordered pairs, but the x-intercept and the y-intercept. Okay? Now, the next thing I'm going to do is I'm going to make another table. So what am I going to do? Hit plus. Okay. I'm going to add a table. And what's my other table I'm going to add? It's a -4, 6, and a 6, -9. Here we go. -4, 6, and a 6, and a negative 9. But to be able to interpret this, now I'm going to have to type in y2 tilde n x2 and x2 plus b. And that's going to interpret this slope. So now let's look at our slopes. Right here, it gives us a 2/3 slope. Right down here, it tells us it's what? Negative 1.5, which is a negative 3/2. But what can you clearly see on Desmos? What can you clearly see? These intersect at what type of angle? Perpendicular, at a right angle. So you can kind of see that they are perpendicular to each other. But this is the proof. What do they have to be? Negative reciprocal. So if you have a 2/3 slope, it's got to be perpendicular to negative 3/2. That's why the answer is perpendicular. Now before I stop this video, I want you guys to look very carefully. You have to know how to do this one. What does this help us look at? It helps us look at, evaluate x1 and y1. What does this one help us identify? x2 and y2. So I'm going to leave this up here so that you guys, right now I'm going to pause it. Make sure that you know how to make two tables. Okay? Alright, so I have a student that has a question about a couple of lines. Okay, so I'm going to go ahead and clear this out. And what I'd like you to do is I'd like you to tell me what you see on your screen. Tell me what it says. Go ahead. Negative 2x plus 2y equals what? Equals 5. Okay? And what does the next one say?
Negative 10x minus 10y equals 5.
Interesting. What would you say that looking at those? What would you say those might be? Perpendicular. Now, here's how you prove it in standard form. How can I find my slopes? Really easy in standard form. I'm going to show you. There's my A. There's my B. There's my C. Here's my A. Here's my B. Here's my C. So let me show you guys right now how to find the slope very easily in standard form without having to do a whole bunch of work. Okay? Here's what I want you to write down. I want you to write, this could be a great example problem in your journal. N equals negative A over B. Right here I'm going to write N equals negative A over B. Okay? So right now, here we go. Let's look at the red one. The red line. N equals negative. What's my A value for red? My A value is a negative 2. What's my B value for the red line? 2. So I get 2 over 2, which is equal to the number 1. For my blue line, if I do negative A over B, my A value is negative 10. My B value is negative 10. These negatives cancel each other out and become a positive, but I'm left with 10 over negative 10, and that equals a negative 1. Just so you know, 1 over 1 is perpendicular to negative 1 over 1. These are negative reciprocals of each other. Therefore, these lines are indeed what? They are perpendicular to each other. Okay? That's how you can compare lines on Desmos. So this answer was perpendicular. Right here, on this particular one, I better check these ordered pairs right here. So I'm going to check the slope. I'm going to figure out how much does that go up, how much does that go over. I'm going to check this slope. How much does this go up and how much does this go over? Because they almost look like they're parallel, don't they? They do. 1, 2, 3. 1, 2, 3, 4, 5. So this slope is 3 over 5. This one right here is at 1, 2, 3, 4, 5, 6, 7. So that goes up 7 and it goes over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It goes over 10. 3 over 5. If you converted that to a decimal, that's 0.6 or 6 tenths. 7 over 10. If you convert it back to a decimal, that's what? 7 tenths. Are those slopes exactly the same? They're not. These slopes are not exactly the same. So even though, if you just looked at it, what might be your first response? You might say, oh, those look what? They look parallel. But what do we have to compare to make sure that they're parallel? Yeah, so these are not perpendicular. They are not parallel. These are neither. They're neither. Because perpendicular, how would they have to intersect? They'd have to intersect at a right angle, okay? So right now, this answer is going to be neither. And how did we prove that? Because what did I do? I found the rise over the run. In case you're a new student, this part is called the rise. This is the run. The rise is the change in y. The run is the change in x. If you're wondering what the heck that little triangle means, it means change in. That's delta. Okay? What's the change in y here? 7. What's the change in x here? 10. They are not the same. So the answer is neither. That's what you're doing on this assignment. What are we doing on this assignment? We are comparing slopes. Are they the same? Are they negative reciprocals? Or are they neither?